All right, starting chapter 8, we're looking at properties of waves. Most of chapter 8 is based on waves. Okay, and so looking at a couple of different things. So, like if we think of waves, we usually think of water. Okay, and so this girl's sitting in a lake. Okay, we can see the waves coming off where she is. Okay, one wavelength is the distance between the tips of two waves, or like the crests is what we call them. Okay, you have two waves, and then the troughs are kind of these dips in between waves. Okay, and we'll go through all of those. Oops. Okay, so looking at waves. Whoops. Okay, so the distance between the one wavelength, okay, represented by the Greek letter lambda, is equal to the distance between the crest and the crest. The amplitude is how high waves are. So, like, and it can be above or below, but it's from like this equilibrium position. Okay, another way to take wavelength would be from like equilibrium position to equilibrium position, or even from trough to trough. Okay, and troughs are when it goes down, crests are when it goes up. Okay, when we're looking at this, so like it says, so A and B are in phase. Okay, and then C, D, E are in phase. So as long as they're in the same part of the wave. Okay, if E was over here, it would be out of phase compared to these other ones. Okay, or A and C are out of phase compared to each other. Okay, waves and rays. Okay, so a ray is a line that indicates only the direction of the waves or the wavefront at any point where the ray and the wavefront intersect. Okay, and so these are not to be confused with vectors. Okay, where like this is showing vectors as the velocity of these waves moving out. Rays are just showing the direction. It's kind of going in all the different ways. Okay, so and waves are or rays are often used to show like reflection of waves and so on. Okay, so we have a surface here. Okay, and we have our source. Our waves are kind of hitting it. Okay, the reflected portion at the incident point would kind of be equal and opposite. Oh. And so, like, you can kind of think of this as like a mirror. Okay, if this is our source and it's going straight at the mirror, okay, the waves are reflected equal and opposite, and then like you have your imaginary incident waves generated by the imaginary source on the other side of the mirror. And so again, like for here, now we have our incident wavefront. Okay, and it's reflected off of here. Okay, you have your real straight wave generator. So if we have a wave generator, this is your wave generator. It causes waves to hit. Okay, and then the way that they are kind of reflected, okay, is based on these points here. And so again, I wouldn't worry about this. We don't have that book. Okay, just read over in your textbook, section 8.1.